Previous session we talk about the tree traversals, how the in-order, pre-order, and post-order travels will work. So in this session, we will try to implement C++ solution for the all three traversals. Okay, just for brief. So these are the in-order traversal we spoke, pre-order, and the post-order. We'll go one by one, and we'll talk about this. Okay, yeah. So here I will try to implement it. I will include IO stream because I want to print some values. Also, I will try to include the vector to store the child nodes to avoid std every time. I will just try to implement the namespace. Let us create a tree node class which will have two values. One is like integer, it is data to store it. Second one is like a vector of tree nodes, actually tree node pointers. That's I can call it as a children. Okay. Also, let us write one constructor so that it will be initialized every time. Okay, that is tree node. It will take integer value, data initialize with value, and that's it. I think we are done. Good to go here. And this children's will be like by default it is initialized to null. Okay, so we are ready with the node now. Okay, so now what we will do is we'll try to see what are in order traversal. Okay, we'll go with in order first. In order traversal, basically this is a three-step process, right? Three-step process is like try to traverse the left subtree and the current node and then right subtree. That is how we should traverse and get the values. Okay, it's very simple. We will use the recursive solution for as part of understanding. Maybe I will try to create a iterative solution sometime later. Okay. Void in order traversal. We will take just a root node. I can make it as a node here. Okay. So if you just check if node is null, nothing to do. This is the base condition for this recursion. Just written. Okay. Right. Otherwise, what we need to do is we need to first statement is we need to traverse entire left node, right? Correct. Correct. So what we need to check is we need to see that if there is any left node is there or not. How we can check that? Check this should not be empty. If this is not empty, that means at least one node is present, right? One that node should be like a right left child basically. In order to traversal, what we need to do is we need to traverse the first node, that is front. We need to traverse this front node basically. Okay, this is leftmost This is leftmost child basically. So this first statement is covered as part of line number 25. Now step 2, that's current node. That means we need to print the current node. That means we are visited this node, this data. Okay. This is just like current node. Okay. Perfect. So now next what we need to is we need to traverse what right nodes. So what we need to do is we need to check all the childrens basically I equal to 1 because first node we already traverse. Then it should be like we need to traverse all the nodes basically from left to right. Okay. So here also we just need to cover in order traversal of node children of I. So if you observe carefully here we are starting from 1 actually not from 0. 0 is already taken care here. Okay, as per the step 1. This is the step 3. Line number 31 is the step 3. Okay. So basically we are done with the in-order traversal. Let us test this one. For that, what we need to do is we need to we need to create a main function. Try to create the root node. Okay, tree node equal to new tree node of 1. We'll try to create same the tree whatever we created we discussed in the theoretical part. Okay, child 1 equal to new tree node of 2 stars child 2 equal to tree node of 3. Okay, so we created child 1 and 2. Thus so we need to push back, sorry, children dot push back of ch1 as the first one and child 2, right? So we are able to construct this particular node, root node, and immediate two children. Okay, that is what we did here now. Okay, so second thing is we need to create next level children's, right? So for that, what we can do is we can create tree node star grandchild 1 equal to new tree node of 4. Similarly, we will create grandchild 2 with number 5. So these things are basically right. We need to create a child 1 children of grandchild 1. Sorry, push back child 1. So now I am creating grandchild for ch1 also. 2 I have created. Basically, what I am trying to do is for 2 I created 4 and 5. Okay, that's what we did here. Correct. Okay, 4 and 5 I created for child 1. Similarly, let us create uh, grandchild's 3 and 4, that is 6 and 7. And these things, what I need to do is I need to create childs for the child 2, whatever ch2, correct. And this one basically, if you observe, this is 3, this is 4. So we are able to construct this particular entire tree. One has 2 and 3 childs, 2 has 4 and 5, 3 has 6 and 7. That is how we built actually now. Perfect. So what we will do is we'll try to call in order traversal of root node. Let us see, like let's compile this and check it out once. What happens? Yeah. So we need to go to cd trees traversals cpp g++. I'll try to compile this code. Let us see how it works. Okay, it is able to compile. Let us run and see. If you observe that actually it is able to traverse very clearly, like whatever we discussed in the our example, like a 4251637. That is like first it will go for the left subtree at the till the end. That is actually 4 will come. After that, it will try to print the current node, that is actually the 2, and its right subtree. Right subtree current it is 5. So that's why 4 to 5. Once this entire left subtree is printed, then it will go for current node, that is 1. That's why 1 you can see. It will go again right and it's left. So it will reach till left, that is 6. Again current node is 3, and again it will go right 7. So that is how actually it will work, the in order traversal. Basically, if you see right here as discussed, so basically it will try to go for the complete leftmost child till it will keep going there till at the end it will reaches the last node. Once that is done, that it will try to print that node, and then it will keep iterating that till it reaches the last node, and then it will go for the all the right children actually. That's how it works. Okay. This is about in order traversal. Let us talk about uh, pre-order traversal. I will just copy these things and I will try to implement that. We'll see. Okay. Pre-order traversal. Okay. So it is very straightforward basically. Pre-order traversal. Very very simple steps actually. We can try to implement that. We'll take root node here. Okay. Okay, so now what we will do is how it works basically. First, we visit the current node, right? Basically, we'll check the null check. I mean, return breaking this particular recursion. If null pointer, nothing to do here. We'll just return, right? Otherwise, what we need to do is we need to, if you see that current number, current node, right? What we need to do is just try to print that value. That's it. Just try to print this. And then now what we need to, we need to traverse all the childs basically. Nothing, uh, because we need to from left to right we need to, if you see right, from left subtree we need to traverse and then right subtree. So we can just traverse all the nodes from all the children basically from left to right. That's it. That's what we left to right. Preorder traversals, the child node. That's it. This recursively basically traverse from left to right. Okay, let us see this how it works. Because we have already tree, I will try to put some new line here. Preorder traversal route. Okay. So what we'll do is we'll try to run this. We'll see everything goes good. Yes. Oops. Oh, we didn't save that problem. Yeah. Sorry. Yeah. If you observe that right in this tree, pre-order traversal is like first what we need to visit the one, right, root node, that is current node, and left subtree if you go this complete like 245, in this again current node is 2, right, that you printed 2. Go left again, if you see the current node only 2. That's it. Once you finish all the nodes, and then you no need to go back and print 2 again, because left subtree of the 2 you already completed, that is pro reprinted. Now what you need to traverse all the right subtrees. Currently we have only 5. Let's say 1 2 4 5. Now entire left subtree is completed, then you can start from the right subtree. Right subtree, what is the current node? 3. Then you go back to left. What is the left subtree? 6 is there, so print 6. What is the right subtree for 3? 7. For root node, root 1, we already covered entire right subtree and left subtree also. So 1 2 4 5 3 6 7, right? If you observe our output also, 1 2 4 5 3 6 7. That's it. So let us talk, let us see the uh, post order traversal. Let us check how what we discussed, what are the steps we need to follow. Okay, so we need to follow basic steps, or like traverse the left subtree, traverse the right subtree. At the end, actually, we need to visit the, we need to, uh, we need to visit the current node. So let us see like how we can implement this. Post order, post order traversal. It's tree node star node. Okay. So base condition for returning this is actually if node equal to null, you nothing to do here. Otherwise, if you observe right, we need to traverse left node. First, what we need to do is we need to check tree node star ch children. So you need to do the post order basically. If you observe that first we visited the node and then we traverse from left to right. But in this case, first we need to traverse from left to right. At the end, actually, we need to, what we need to do is we need to uh, visit the node. Third step, right? So this particular 2062 and 63, this is actually covers both step 1 and step 2, because from left to right we keep traversing, posterior traversing we are doing. So now what we need to do is we can print the node value here. Okay. Okay. Basically we are processing the current node here. Okay, let me save this file, and we will call this one here. Let me write the new line here. Post order traversal of route again. Let me save this, clear the terminal. Okay, let me run this one. Okay, compilation successful. If you observe the last one, like 4526731, let us go back to our tree. So 452, just see, 4526731, right? That's it. So if you see, right, we are traversing uh, till left actually, right? Left node and then right node. Like in this case, like you will keep going left till 4. That is left node. One that is visited, then we'll go for the immediate right. Okay. After these two are done, then we'll try to visit the current node, that is 2. So Prometheus left subtree is done. Now we will go for 2's right node, and it's left actually, complete left, and 3's left is 6. So we will print the 6, 6 doesn't have anything. After that we will print the 7 because 3's right, whatever nodes we have, that is 3 now, 7 now. When this 2 is done, then we'll visit the current node, that is 3. And now it is right, entire right subtree also completed, then its current node will be like a 1. That's why we'll see the end, at the end we can 1. Okay, this is about the recursive fashion of recursive solution for the tree traversals, basically all three traversals. That's it.